share the screen. Okay. Let us go through that again, whatever happened, what happened. So we are just going with the car data here for the random forest, and this is the shape of the data. We are having to 301 rows and 9 columns, 9 features or 5 features. So this is the data frame. This is the data frame we're having. Uh, so in this data frame, if we describe this the statistical thing from this particular data, the count, mean, standard deviation, median, all these things. So we are so these are the so in this final data set we removed some of the things here, like I think we added some more thing here. So year, selling price, column names for it, and this is a final data set. And the final data set, this is the head, this is the top 5 values and this is the last 5 values. And we are adding a new column here called as current year in 2020 and assigning value 2020. So every row will have the same value. So in the final data set, since we added this current year, this is the new column, the last column. And after that, we added a new other new column called as no underscore year, and it is a value in which, like, we are saying no year, nothing but the current year minus year. We already have year in our this data set, and since we added current year, this no year is nothing but current year minus year we are having. After this, we drop this year, since year we don't require. We're just going with a no year, and uh, if we just drop that, and after that, these are the I explain you, right, like get dummies is nothing but to we don't need any values, which has this wording like this, like a manual, dealer, petrol. So we are eradicating all these things. We are converting everything into a numerical format, because a random forest only deals, it only understands the numerical values. So that's the reason we use this particular new function get underscore dummies and transform all this ones which are having a wording details like this, like into this one. For example, fuel type, here fuel type has been assigned with the 2 other columns, since there are only things here, petrol and diesel. So that's why we are having fuel type diesel and fuel type petrol. 0 or 1. 1 is petrol means yes. 0 for petrol means 0. So which means this is a diesel value. So likewise, and seller type, we are having seller type, we are having dealer. So dealer is 0 and the other one is 1. We are pretty much we are having all the zeros here. And the transmission, whether it's a manual or no. So seller type we are having, one is individual, and the seller type we are having is a dealer, because one is we are having most of the values as a dealers and the other one is individual. But individual we are having zeros. We don't have any pretty much individuals. Everything is dealer. So after the transmission type, we are having pretty one value. So that's why we are having transmission manual. That's why we don't have any other thing. Transmission manual, everything will be one, because everything here is a manual in the data set. So that's what we are doing, get dummies. So till this extent we had done in the last class. So let's continue this. see the correlation for this. I mean, how they are correlated. That I told you, right? Correlation is like how much a particular data set, let's say how selling price is related to present price, how selling price is related to kilometers driven, all these things. So this is what we are having. One is the best correlation value we can get, and then zero is the least one. Sorry, minus one to one, it varies. Here we'll have one value, and in the last one we'll have one value, because these are directly correlated, one and one, because here selling price is related to selling price. Obviously, if Sandeep is compared to Sandeep, it will be one, right? So exactly that way, selling price is related to selling price, it is having one value. And here we are having transmission manual, the last one, and here also transmission manual, that's why we are having one value. So what I'm saying, trying to say is, here we are getting correlation of all the existing columns, column wise. So after this, once we have the correlation, so we are importing Seaborn as an SNS. I told you, right? Seaborn is also on the library for visualization. So just like Matplotlib, Seaborn also does visualization, but Seaborn is having much more can able to give us plots in terms of complex wise, rather than more than this Matplotlib. Matplotlib also does this, but it is having some simpler diagrams like bar graph and other small graphs. But with Seaborn, we are having some complex graphs like a pair plot. I told you about pair plot, right? Pair plot is nothing but just like this, just like we'll be getting same this values also in pair plot, but in terms of graphical representation, that's the only difference between this correlation and pair plot. Correlation is just like in terms of numericals we are getting the values, but in pair plot we'll be getting diagonal representation of the values. So that's the only difference. Now let's let's give some time to have the pair plot, which is the all the existing relationships between the columns in terms of graphical way. Yeah. Okay. Let's see. Or let's see this particular. Selling price current year. So, for example, this particular graph is nothing but the plot between a selling price and the year. So, year is always the same. I mean, so this is how the graph looks like, because let's see the values here. Selling price and year. This is a selling price. Oh, that is not a correct representation, because selling price and year, it doesn't make any sense. So, but let's see the present price and selling price, because both the prices, present price and selling price. Okay, so here this is selling price and this is a present price. So 3 point for selling price 3.35, the present price is 5.59, 4.75, 9.754, 7.25, 9.85. So present price is somewhat more than the selling price, but it is a bit more directly proportional. So for 3.35, it's almost price and price is getting doubling here. 4.75, it's almost double. 7.25, a bit more than 7.25. So it's pretty much a bit more. So that's why we are having this value present price. So somewhat some of the plots here, some of the points here are directly proportional. Some points are like going here and there. And this is this we are calling it as like I mean out of the boundary that so these two are having some weird values. We are calling this as outliers. We already talked about outliers. If some points are very unlikely to happen and which doesn't go with the other flow, that we're calling it outliers. So rather than this, this is generally actually following the trend. So yeah, that way we can able to see the relation between with all the columns, the existing columns of selling price to present price to kilometers driven to selling price, all these things. But some are irrelevant because selling price and year, no year doesn't make any sense. So we need to see like which columns might have. The reason for us to have pair plot is like to find out how columns are related to each other. Now after this, no, generally after this, what we'll do, we'll try to find out. We should give what is the x value, what is the y value here, right? Because we are having final data set here, and in this we need to see what is x and what is y. So this is the x value. I told you right, in ilog the before comma everything will be the rows here, and after that this is columns. So before comma it's rows, and after comma it's columns. So I'm considering all the rows here, and I'm just going from one to all. I would be my columns. So which means I'm eradicating my first column here. So that's the reason. See, I don't have present. I don't have selling price in my X. So which means selling price would be my Y value. So selling price would be my dependent. So selling price is the one which I need to find out for the new columns. Okay, so that's what it is. Now let's see what is Y is equal to data with iLock. I'm considering all the rows, of course, and this is my column. Okay, because 0 is my first column. 0, I told you, right? 0, 1, 2, 3. That's how the Python works. In Python, always it counts with 0, not with 1. So that's the reason we are saying I want only 0 to be my Y value. So that is what. So here my selling price would be my Y. Mm, Oh, sorry. So it is D should be small. I told you, right? Python is case sensitive. Okay. Yeah, this is Y value. Yes. So if I see here, in X, owner looks, everything looks zero. I just want to see how many unique values are there. How many, is there any other values or not? Because this looks like everything is zero. I mean, for example, what I meant to say is, if everything is zero, there is no reason for me to use this particular column. I already told you, if the number of columns increases, then the complexity of the model will increase. So we don't want a model to get more complex enough. So it's better to remove as many columns as possible. I told you, right? That's what we called it as feature engineering. In feature is nothing but to remove the columns which we don't require and to try to find out the relationship with all the values. So that we got to do by doing particular this kind of tests. Like for example, if you see here the data from this data final data set, it looks like for me every owner here is zero, so it's not adding any information to my data set. So I just want to see whether any other than zero are we having anything or not. So that we gonna do is by unique. Oh, nice. So what happens is it's not like we're having only zero values. We're having ones and threes as well. So 1, 2, 3. So yeah, we're good. Okay. So, let's know what this is. Uh, mm, 1 second. Once again, I'm trying to find out. I mean, I'm getting some weird values here. So that is not the case. Mm, So yeah, what I'm doing here is like, I mean, I'll try to solve this. But the thing is, so we are having these features, right? I mean, the X features and Y feature here. So I'm trying to find out how much a particular feature is really important to me. I just want to find out. So just so that I can just remove if a particular feature is not really contributing to my model. So that's what I'm doing here. That's the reason I imported this particular thing called as extra trace regressor. So I'm just assigning this to model. I'm just having this variable name called as model here. And with this model, I'm just fitting this with my X and Y values. After doing that, I'm just trying to print out this particular how much, what is the values for this, what is the result for this particular, and which means like 3.69. So this is my, this is how much a particular present price is having, and what 4.07 is a kilometers driven, who is the owner. So this is 3, and current year it's not give me any sense. No year it's giving me a lot of sense. So which means we can able to find out whether uh, a feature is really contributing to my model or not. So that's what we're doing. Sorry, your voice is breaking. Sorry, your voice is breaking. Hello. Hello. Can you type this here in the chat, because your voice is breaking. Oh, okay. So uh, extra regressor determine the values to eliminate. Okay, it's not like so it is more like I told you, right? This is about feature engineering. So we want to try to find out how much a feature is really contributing to our model. So with this extra regressor, so this is nothing but the metric we are having, the result of the metric. So this is like, for example, let's say 3 times, for every 3 times of a present price, 4 times a kilometer driven is actually contributing, which means kilometers driving is more contributing than the present price. So that way we are trying to find out this particular features are contributing to our model. For example, here somewhere we are having 0, which means it's not contributing me anything, which means we can actually eradicate this particular 1, 2, 3, 4. 1, 2, 3. We can actually eradicate this current year. Got it? So this we are doing it for the feature engineering perspective, extra trace regressor. Yeah. Okay. Oh, okay. But actually, I'm just seeing like give me a second. I want to run this again because there's not the values I'm expecting in terms of feature importance. It will be more like a 0 0.3, 0 0.4. I mean, like that. I don't know. Mm. Oh, okay, okay. Somewhere I messed up, but now it's getting values. For example, see here, like 0.38 is a contribution. I'm getting it from the present price, 0.04. So which means present price is much more important than the kilometers driven. So when I'm trying to sell my car, so these are my features I'm taking into mind. So present price, kilometers driving. The second one is 0.040, 0.00040. This is a third value. Third value is very worst. I'm not considering this. One, two, three. Owner, it doesn't matter because anyway, it's having most of the things having zero values. It's not giving me any values. The fourth one, it's not. Let me run this again. I'm getting 0.7. Okay, that's fine. After that, owner, current value, no year. What is my final value? 0.144. Transmission manual. This is also counting me. Seller type individual. Seller type individual also it's contributing me a little bit. So the best I can 1, 2, 3, 4. 1, 2, 3, 4. Yeah, fuel. So what's happening is present price is contributing, kilometers driving is contributing, fuel type diesel or petrol is contributing, seller type individual, transmission manual. These are the things which are contributing to my particular model. So after this, let's have the same thing in the let's have the same thing here in the graphical representation. So for example, feature importance was so what I'm doing is I'm actually representing these particular values in the graphical way. That's it. I'm not doing it because with the graph you can able to easily determine I mean the values right more than this always it's better to have a graphical representation rather than just having the values itself. So what I'm doing is actually with the same feature important. For the feature importance is I'm giving index as x columns. It's just like you don't know what is what here, right? So I'm just labeling the values. For 0.038, it is nothing but the present price, like that. Hey guys, yeah, sorry. So what's happening here is, so I'm just before we don't know what 0.038 is like. I'm just saying based on the data. I'm just trying to see here. It's up, I was juggling here. So rather than that, so 0.36. So which means present price is having the highest contribution here, and fuel type diesel is the second one. The transmission manual, seller type individual, and no year. So these are the ones which are actually contributing to my this thing, because I'm giving largest five values. If I want to see largest 10, I can also do that. Okay. So the current year is not actually contributing because if you see here, current year is always 2020. It's not giving any extra value. Owner, it's not giving me anything. Fuel type petrol. Fuel type petrol also is having less value because most of the values here are, I think, yeah. After that, kilometers driven. Next, no year. Next, seller type individual, transmission manual, fuel type diesel, and present price. So with this, we are actually find out like top 10 contributors to our model. So what I'm trying to say is, if I remove this owner and current year, still the model won't get affected. The reason what I'm trying to do here is I'm trying to do the feature engineering. With this, I'm trying to do the feature engineering to eradicate or to remove some of the features from my model to make it my model as simple as possible. I don't want my model to get complex enough. So that's what I'm doing here. But uh, uh, since we already have this, but in future we're gonna use this owner or current year here again. So I don't want to remove this. But again, I just want to show you like how much a particular thing is contributing to each other. So let me go again here. So I'm just trying to split the data into my test size is 0.3, which means my test size 0.3 and my train size is like 0.7. So I'm having split of like 70-30, which means, for example, if I'm 1,000 values, 70, 700 I'm giving it for training and 300 I'm giving it for testing. And this is how I'm doing my test split. I did the same thing which I did in my last model as well. So now I'm importing my main model. Oh, okay, guys. I think it's past 8. So let's continue class tomorrow. Tomorrow, can we class start the class at 7 o'clock, because we are having like a 20%, 20 like 20-25 minutes delay in the starting. So if we can able to have a 1 hour class, we can able to complete this and other model as well tomorrow.
Sure, Sandeep.
Okay, thank you.
Thanks. Bye.